Okay, my mic is on now. So chapter 9 is basically going to involve more inheritance topics. The polymorphism is where inheritance becomes more important for object-oriented design, and that's what we will be covering in chapter 9. And we will have examples that will make more sense in terms of inheritance as well as we go with this chapter. And to start with, the contents of the chapter include how polymorphism can be defined and how you can use inheritance to create polymorphic references for your objects, and then how you can use interfaces and also additional GUI components again to implement in our designs. So that's the main coverage of the chapter 9. So polymorphic references. When we say polymorphic references, one of the main important things is that binding. Binding is what we mean by a method when we call the method. So for example, whenever you say object.doIt, what does this mean is actually binded to the doIt method. However, if you have multiple definitions of the doIt method, which one of these methods is going to be used depends on the object. Right? Whatever my object is, it's going to depend on that. So to identify that, what you have to do is you have to bind this method to the correct object type. Okay? So what kind of object you're going to use depends on the language of the programming that you're writing in. And in Java, this is done at runtime, which is called late binding. So Java looks at the object at runtime, identifies what type of object you have, and then uses the corresponding method that refers to the object. So it will be more clear as we go. It might be confusing at the moment, but it will be more clear. Late binding provides flexibility in programming design. That's the main feature of polymorphism and what is used in Java as well. So the polymorphism literally means polymorphic, so it goes into different shapes, different kinds of forms. So it means many forms that it has. And a polyformic reference is a variable which can have different different implementations if you have a different object for the same method. And the method invoked through a polymorphic reference can change from one invocation to the next, and you need to look into the object that is calling the method. And all methods in Java are potentially polymorphic, so you have to see the execution at runtime. And again, I will have example to make it more clear. So suppose we create the following reference variable, occupation job, and then I would like to have this job to have a different type of object. That's possible if my object type that I would like to create is compatible with the object occupation. So this applies directly into the parent and child relationship. So when you look into inheritance or interfaces, you can see this relationship. If they are related using an inheritance or interfaces, you will be able to assign one object to the other type if they're related. So for example, if you have another job type which is hard job, let's say, you have a subclass of job which is hard job, and you can assign occupation to a hard job object as well, because it's the parent class which can be utilized to be used as a child class. So in using inheritance, you can create polymorphic references. For example, an object reference can refer to its subclasses. So if the holiday class is used to derive a class, so you have a holiday class, and then you have a Christmas class, which is a holiday. Okay. When I create this, if I have a holiday reference that I created, so I have a variable that I say holiday A, okay, and then I say that A is equal to new Christmas. So this is going to be possible because it is the parent class which can be which can be assigned to its child. Okay, so you can create a child class, child object, and then assign it to the parent. And whenever I say, if let's say both of them has a doIt method, so holiday has a doIt method, and then Christmas has a doIt method as well, which is overridden by this method. When I call a.doIt, what's going to be used as the method? It's going to use the Christmas's doIt method, because the object that you are referring to is now a Christmas object. Although it is initially defined as a holiday object, as a variable, now the object itself is a Christmas object, so it's going to call its corresponding method, the Christmas method. Although if you look into here, it's defined as a holiday. So if you happen to, then there's, let's say, another class which is generated by Christmas, let's say a Christmas, okay, and it's subclass which has another doIt method, right? If I say that a equals, okay, and then I say near a Christmas, and now I create the child of this, and then I call a.doIt. Now it's going to call this time this doIt method. Okay, so it's going to depend on not the variable name, but the object it is referring to, which method is going to be used. Again, they have the same name, overridden methods. However, you choose the corresponding method based on the object that this variable is referring to. Okay, and this is called polymorphism. So in different places of the code, it has different meaning. It uses different methods. And that's what exactly polymorphism means. And it has different forms as you go in the code. And this is late binding because the compiler looks at it at runtime, which object it refers to, and uses that reference, in this case, a Christmas, and uses that corresponding method at runtime. That's why it's called late binding. However, if you were to look into the code initially, you would say that, hey, this is type of A, so I will use always the type which is holiday's doIt method in the early binding. If you're using late binding, you will use this way. However, if it was early binding, you would have start with holiday type and use its methods as you go. Okay? So this is same thing, holiday day, and then you create new Christmas object, and then if you use day dot certain method, it's going to use the Christmas's method. So when you look into this references, assigning a child object to a parent reference is considered to be a widening conversion. So you, using the parent, you widen the description of the parent and use it for a class. So it can be performed by simple assignment as we did here. So I created a parent class object variable, and then I used that to create a child class. So this is widening the description of the variable that you have initially. The reverse is parent object to a child reference, but this is called a narrowing down conversion. So you're going to create a Christmas object. However, you'll cast it to a holiday object later on. This is called a narrowing conversion. However, it's not really useful, this narrowing conversion, because you have to make sure that these narrowing down, the casting is possible, and it's going to be successful. Which, usually done in Java using instance of. So instance of tells you that whether it is possible to create a holiday object by using a Christmas variable. So you'll, if A instance of B will return you whether A can be, A is an instance of B, and this way you will be able to do the narrowing down conversion. However, it's usually hard to do that, and most of the times you will get a compiler error if you don't have the compatibility to cast to the narrowed down, classes in the holiday. So this is explaining the same thing. It is the type of the object being referenced, not the reference type. So initial declaration is not important, but what it refers at the moment is what you care for. And suppose the holiday class has a method called celebrate, and the Christmas class overrides it. So as we said with do it, you have a celebrate method in both of these, in which case if you call for the day.celebrate will refer to, obviously as we said, to Christmas. So if you call day.celebrate, it's going to basically, since it is referring to a Christmas object, it will call the celebrate method of the Christmas class. So let's say you have a class hierarchy, something like this. This is a similar thing that you have seen with the quiz question. So you have a staff member, which is the base class for the whole hierarchy, and then you have a staff member, which could be a volunteer or also an employee. And then for each employee, they could be executive or hourly. And then you can have additional staff that you would like to add into this hierarchy structure. And if you would like to write the code for such application, these are the classes, as you see, a lot of them. Although there's a lot of classes there, it's not really that complicated. So let's go and see executive. And then what else was there? Staff member, volunteer. So that's... And if you look into here, this is the base class, which is staff member. So as you see, it is defined as abstract public class staff member. And again, you cannot create a staff member directly using this. And you have protected string name, address, and phone. And then I have the public staff member, which is basically going to, construct the object with the name, address, and phone number given for that staff. And then you have the toString method, and you have an abstract method, which is going to public abstract double pay, which is going to basically an abstract method which will be implemented by the classes of that hierarchy. So any question? And I have, if you remember, within the staff member we had, let me go there. So this was the hierarchy. So I have a volunteer and employee. So let's go see the volunteer. If you go into volunteer, public class volunteer extends staff member, and then you have the constructor for the volunteer, which is basically going to call the constructor of the base class, the abstract class, with the super, and it's going to call this constructor with the corresponding arguments, right? So in your constructor, the first thing is to call the parents constructor, which is done here. And then it is going to have since it's extending the staff member, which is an abstract class, and it has this abstract method, it needs to implement this. Otherwise, if it doesn't implement, what's going to happen? It is going to be an abstract method as well, because it doesn't implement the abstract method, so it needs to implement them. Otherwise, it will be an abstract method as well. So basically, you implement this abstract method and then return 0, since this is a volunteer. And we had the employee. So public class employee extends staff member. If you look into here, again, you have the protected identifier, which is a string, social security number, and then double pay rate. This social security number is something like TC kimlik number. So it's basically for the same reason. And then you have the public employee, which is going to basically, again, create the object with the constructor, with the arguments of all these given. And you have, once you have the constructor, the first line of the code is going to be to construct the parent class, which is again the same thing, super with the name, address, and phone. So it will use the staff members constructor. Then I have the social security number of this object to set to the argument, which is given here with social security number. And I have the pay rate equals the assigned argument. So basically this is performing the parent class's properties, create that, and then On top of that, whatever is remaining, I need to construct that here as well. And if you see, there's a toString method, which is going to be overridden, right? As we did here, the toString method is written here already. However, I am overriding that toString method in my employee, so that it's going to call this toString method. So when I use the object as a employee, it is going to refer to this toString method. However, if I use it as a, however, you can't do that, but if you were able to, if it was a staff member, it would have been the toString method that is part of the staff member. And then anything else? Yeah, you have the pay method, which is abstract method in the staff member, and here it's implemented return pay rate, which basically returns the this instance variable, the pay rate. Okay, and if you look into the hierarchy, we have executive and hourly. So if you look into those, executive, public class executive extends employee, so it's going to be a child of employee, which is going to have an additional bonus instance variable, which is type of double. And then I have the executive constructor, which will call which constructor? Since it's extending employee, it will use the parent, which is the employee, that constructor. So executive first will call the super, which is the employee. Whenever it's going to be created, that constructor, it is internally will call this constructor, right? So which is going to call the staff member constructor. So executive will create the object, and then in addition to that, it initializes the bonus to 0 for that constructor. So the initial value will be assigned to 0. And then it adds additional methods which were not part of the employee. However, executive adds more methods, and in this case award bonus, and then it equalizes this argument to the bonus. And it also implements, what does this pay do? It is going to basically override the pay method of the parent class, which is implemented in employee. If you remember, employee had its own pay method. Now this is going to override, and whenever you call the pay method, it's going to call the executive's pay method, if the object is an executive type. Okay? And then we have an hourly employee, which is going to, again, extends employee. So it's going to have all the properties of an employee. On top of that, it's going to either override or add more stuff to it. So in this case, it adds hours worked, since it's an hourly worker. And then you have public hourly, its constructor, which is going to basically, again, call the employee classes constructor. Since it's extending employee, it will call that constructor. And hours worked is equal to 0, which initializes its own instance variable. And when you look into the add hours method, which is specific to this class only, it adds this hours to the number of hours worked. And it again overrides the pay method of the employee, which in this case is going to be just multiplying the pay rate times the hours worked so far. And that's going to be the pay method. ToString again is going to be, overridden by this ToString method as opposed to the employee class. So if you call an object and try to print it on the screen, an hourly object, it is going to basically call this method instead of any others, because you have the current hours worked and blah blah printed on the screen. So if you look into the staff.java, so it's creating a staff member list, and then for each one of them you create the objects. So you have the staff members, and for each staff list 0 you have new executive, you create the executive, and then staff list 1 new employee, staff list 2 new employee, again another one, and you create a third staff list 3 new hourly. So you create the hourly object, you create the volunteer and another volunteer, and that's about the 6 staff list that you have. And then you also call these methods specific to giving awards to the manager. So you give the executive staff list 0 and then award bonus. As you see, since staff list is defined as a staff member, you have the typecasting indicating that, hey, I know that this is an executive. Although it is a staff member type, it can be seen like that, but I already know that it's created as an executive, so I give that cast in front and say that, hey, award this bonus, so which is going to just call the award bonus of the executive class. And if you look into the hourly add hours, you again indicate that although this is shown as a staff member, however, it's not a staff member, but rather it's an hourly object, which is, which I just created here, new hourly. So it's going to, prevent having an error indicating that this is an hourly object, and I add these hours. So if you wanted to write this without the hourly, for example, here, you're going to get an error because add hours is not part of the staff member. So this is not part of the staff member. You can't find that method, and which is part of the hourly, which is shown here, add hours. So you have to, cast it saying that, hey, I know that this is a type of hourly object and I would like to use its corresponding method. And if you look into the payday, it's basically double amount, and if you look into this for loop, what does it do? You have int count 0 and then count staff list length, so it's going to start from the first entry of this array and staff list, go all the way to the end. And what it does, it prints the staff list count. What is it going to print here? For each staff member in the staff list, what is it going to do? It's going to call the toString method of that specific object. If it's an hourly, it will call the hourly toString. If it's an executive, it will call the executive's toString object. And then amount, staff list, count, pay is going to call the pay method. As you see, this is the polymorphic reference that is shown here. Why is it polymorphic? It depends on the object of the type in the staff list. If it is an hourly, it will call hourly's pay. If it's a executive, it will call executive's pay. So at the moment of the execution, you don't know which pay method is going to be called. However, it will be known at the runtime, and it's going to use that corresponding pay method. And if amount is equal to 0, it will say thanks, so that it means it's a volunteer. Otherwise, as system out print line paid this blah blah amount, and then it will print that lines at the end. So if you look into the firm.java, basically it is creating the staff object, which is this one, and then it is calling the payday method of the staff. So you could have copied it here and execute the whole thing here from as well. So if you wanted to execute this, so as you see, it uses the corresponding toString method and then calculates the amount based on the method, and then prints them on the screen one after the other one, as the for loop was doing. So it was, if you remember, it was 2400 something. Now it's 29 because of the deposit that you have. Similarly for hours worked, if you remember the current hours, so this is different toString method because it's an hourly worker. Remember, it was printing the number of hours worked so far as well. Any question? Everybody understands polymorphic references and polymorphism? So basically it is, the object types that you should be caring about once you are calling the methods, not the initial declaration of the objects or variables. So this is performed using the inheritance polymorphism through inheritance, because we inherit the properties of let's say the staff member onto the employee, and also to the volunteer, and from employee to the executive, and also hourly, and so on. However, you could do this also using the interfaces. So if you have multiple interfaces that have been implemented in a hierarchy, again, there must be a class hierarchy or interface hierarchy to do this. If there is such a hierarchy between the interfaces, what you could do is that you can generate the polymorphism using the interfaces and use the specific method that is referring to the current interface. So if you have an interface that indicates the object reference, so for example speaker current, the current reference can be used to point to any object of any class that implements the speaker interface. So let's say I have an interface of type speaker, and then I have an object variable that I define as current. I can refer to any object that is implementing speaker as my current object. So let's say I have another class. So let's make it more clear. So if I have public class and then S speaker implements speaker. So, and then I have the internal implementation of this, whatever the implementation is, doesn't matter. So if I have this, whenever I say speaker and then A, I can assign this A to be of this class type. Anything that implements this speaker. So I can say new S speaker. In which case, it's going to create this S speaker object because it implements, this speaker interface. So you can create the same thing using interfaces as well. So whenever you say the version of the speak that the following line invokes depends on the type of the object that current is referencing. So it's going to depend on which object type you're using currently. So if you have, let's say, another thing A equals new B speaker, which again implements, let's say, another class that implements the same speaker, then it's going to depend on the type of the object class that you are creating the object from. So in this case, it's going to use A speaker. In this case, it's going to use the B speaker's method call. It's same exactly as inheritance, but instead you are using interfaces. This is also very useful when you use it. So same example, if I have current.speak, it's going to refer to the object that it exactly matches at the runtime. So if I have two classes, philosopher and dog, which implement the speaker interface. As we said, I have this interface, which is the speaker, and I have two classes, philosopher and dog, which both of them implement the speaker, in which case like A speaker, B speaker. And I have a speaker guest new philosopher, which is going to basically create an object of type philosopher, right? And then if I say guest.speak, it's going to call the philosopher's speak method. And then when I say guest new dog, it is going to create a dog object and assign my guest variable to point to that reference. And whenever I say guest.speak, it is going to call the most recent object, which is the dog's speak method. Okay? So you can use interfaces to create polymorphism as well in your implementation. Sorting. Any question about polymorphism? So again, if you have lines of code that is executing in an application, you should pay attention to what kind of object that variable is actually referring to and use that method to print or to execute or whatever is going to happen. So this is, again, a common type of exam question. So you have several polymorphic references into class variables and methods, and then you call, you create the objects in this fashion and call one of the objects method, and then ask you to find out what will be the output, what will be the last values, what's going to be created, and so on and so forth. So it's basically easy thing, but you have to understand the logic behind it. So if you have any question, you can ask me, or we can talk later on as well. So sorting, you have seen sorting in CS 101 briefly. However, it's a really wide topic which which needs to be explored if you're looking into it. So you're basically arranging things in an order in sorting, in any sorting algorithm, and there are many algorithms that has been implemented depending on the efficiencies of the sorting algorithms. So we will deal with selection sort and insertion sort. Which one of these algorithms have you seen? Selection sort you have seen before. What does selection sort do? So it, as the name suggests, it selects the corresponding element according to a certain condition, right? So in which case, for example, if I have, we're going to come back to polymorphism along with the sorting. So don't worry, it's just jumping here and there, but it's basically going to use sorting to sort things, to use polymorphism in it. So let's say a selection sort. How does selection sort work? So if I have 3, 5, 2, 1, 6, and 9, what am I going to do with the selection sort? Basically, if I'm going to sort ascending, meaning that from minimum to maximum, right? What am I going to do? I will select the minimum among the whole list and then move it to the first position. So that means I will select the minimum among my list. This is my list. I will select the minimum, which is this one. So I will move this into here, which is performed by a swap. So I will just replace 1 with 3, so that 3 will move here. So now I know that the minimum has been in the first location. The rest must be sorted. I know this part is already sorted because it is the minimum. Then what do? I find the minimum among this list, which is this one. So I will swap it with 5, which is going to basically make this 2 and make this 5. Now I know that this part is going to be, this second element is now the minimum of this part. So I know that so far I got this part as sorted. So this is going to be sorted. This part is unsorted. And then I go and select the minimum of this unsorted part. Find that this is 3, so I swap it with 5. And now my near unsorted list will be this part. Sorted part will be this part. And then unsorted will be this part. And I check the minimum. I find that this is 5. So there's no need for a swap, or you can swap it with itself, doesn't matter. So it will be remaining as it is. And then same thing, you'll check 6 and 9 unsorted, find the minimum. 6 is minimum, which is in correct location. So you don't need to check the last one, because last one must be the maximum, right? So that's the selection sort algorithm. And basically it is selecting either minimum or maximum and moving things around. Any question? So, you select the value and put it in its final place into the list. Repeat for all other values, which is what we did. Find the smallest value, switch it with the first position, find the next smallest, and switch it to the next position. So what are the things that you need to implement here in order to be able to write the code for this? So if I ask you to write the code for selection sort, how would you write it? So basically, you need a loop, right, to iterate on the indices of this. For example, I give you an array, let's say selection sort, okay, and public int selection sort, and then I give you another array, int a. And I want you to sort this array and then return me a sorted array as a result. How would you write the loop for that?
array, and we change the minimum and in combination we find the minimum of array, and by using loops we continue this progress and we sort the array.
Exactly. So what you have to do is that first you need to think about this as a whole application. Once the thing is that first you need to have a loop that is going to iterate on the currently thing that you would like to insert the minimum value. So it will start with this index 0, which is going to be your outer loop, right? So that it's going to say, hey, I would like to start int I equals 0, and then the rest you can write based on the length of a, and you increment the value by 1 every time. However, this is going to be the place that you would like to swap with, the minimum, right? So that's what it is keeping in track. And then you need to have another loop. What is this going to check? It is going to find out the minimum among the remaining things, right? So this is going to, int j is going to start from where? It's going to start from the next thing, which is this one, so that you will start with I, and then I'm not going to write the rest again, and so that if this one and this one, if you find the minimum among this as to be initially this one, what you have to do is that you will need to have a swap. If you will have here, if min is greater than this, let's say your array is here aj, then in that case you will swap the min to be aj. So you will find the minimum here and its location as well. It's not sufficient to find the minimum among the remaining list, but also you need to find the location of that so that you can perform the swap between those two elements. Okay? So if we wanted to write the code, if you want to write the code, we can write it from scratch. Would you like to write it?
Mesela ilkinden başlıyorum. Ondan sonra geri kalanlar için ondan küçük gördüğümüz zaman değiştirelim abi. O da yapmayacak. Aynı şey. Yine 2 tane for loop sadece.
That same thing, that's called insertion sort. You can do it many different ways, but selection sort specifically selects the minimum among the list and puts it into the correct position of the minimum, and then continues with the remaining list. So that's basically how it is going to operate. So if you, however, if you want to do it as an insertion sort, I will show that to you as well. You can do that too. Both of them have the same complexity in terms of the number of iterations you need to perform. Both of them will be on square actually. So this is just showing the effect of selection sort. Again, you select one as the minimum among the list, and then again, what I'm saying is that since you have to put it into this location, you will search for the minimum as well as its location. So you need to keep track of the location, and then you can swap these two things. Similarly, once I got this, now the next location I need to insert is here. I will find the minimum with the for loop. I found that this is the minimum, and then I will swap it with this location so that they will have the entries swept over and over. So that's basically the selection sort algorithm. And each time you find the smallest element. So how does the swapping perform? How does the swapping is performed? How do I perform swapping in general? So let's say I have an array element A. In this case, I'd like to swap AI with AJ. What am I going to do? I will say temp equals AI, right? So that I keep track of the value that is stored in AI into temp. And then I will say AI equals AJ. And then next thing is AJ equals temp. Right? The reason is you need to have one temporary position to keep track of one of the elements so that you can perform the swap. So this is exactly what's shown here. Polymorphism in sorting. So this is where I wanted to come into. If you remember, we have the comparable interface. So what was comparable interface doing? It had a single method which was compare to. Okay, so you can use polymorphism to develop a generic sorting algorithm. Once you sort a comparable object, you can sort names, you can sort objects, you can sort cars, for example. If it is implementing a comparable interface, then you can use that sorting algorithm for any object. So for example, if I have a class public class cars implements comparable. Okay, whenever I create this, I say that, hey, car has a method that says compare to method is implemented within this cars class. So whenever I want to call an object and its type of comparable, I can use this compare to method to sort things around easily. So there's an example which I'd like to show you, which is going to, which is going to be really neat to see. Phone list and sorting. So let's see that. And that's going to be the last thing I'm going to show you today. Phone list and then sorting. Is there anything else? Contact. So you have public class contact implements comparable, as I said earlier. So it is implementing the interface comparable, which is basically composed of first name, last name, and phone number. And you have the constructor, which basically assigns the arguments. And you have the toString method, and you have Boolean equals, and you have obviously the compare to. Why do I have the compare to method? Because it is implementing the comparable. Right? Interface has the comparable compare to method, so you have to implement the compare to method. Right? Do you remember the comparable interface? Implements comparable. Comparable has compare to method. That's part of the interface. So you have to write the code for the compare to method. In this case, it's going to take an object as an argument, and then it is going to cast it to the type contact and get first name, get last name, and if it is equal to the first name of the current object, it is going to return true, otherwise return false. Okay, so here I have if last name equals other last, result first name compared to other first, else result last name compared to other last. So it's going to basically return true or false based on the string comparison. And if the first names and last names are same, then it's going to return true. Otherwise, it will return false. So the first thing checks if the last name, the string, is equal to the other last, which is the object, the other referenced object's last name. Then result will be based on the checking of the first names. Otherwise, if the last names differ, then that means it's basically last name compared to other last, which is going to just be false. Actually, this is returning an integer. Sorry, it must be either positive or negative value. I'm sorry. So it's checking the compared to if it is going to if the last name is bigger. If the last name is equal to the other last name, it will check the first names. Otherwise, first names. Otherwise, it will compare the last names, and according to that, it will give a 0, positive, or a negative value. So when you look into the sorting, let's go into the phone list. So if you look into the phone list, basically what it does is that it creates an array of contacts with 8 entries in it, and then it creates all these contacts with the constructor. Then what does it do? It calls the sorting selection sort friends. So it calls the friends array, which is a contact array, and sorts this array and prints it on the screen after the sorted values. when you look into the sorting basically public static void selection sort comparable list. So this is where it is actually important. As you see, it is using a comparable array of elements. The name is list. So it's going to basically accept any comparable object. In this case, they are going to be contacts, right? And for each contact element, it's going to compare them and sort them according to the selection sort. If you look into here, this is selection sort with comparable objects, and this is the insertion sort with the comparable objects again. Again, you can call them with any type of comparable object. It could be contacts, as in this case, or it could be cars, it could be numbers, it could be, whatever you can call with as a comparable object type. Whatever implements comparable, you can use that. And in this case, you are sorting the contacts based on the values of the first and last name, and this is shown on the phone list. So if you execute this, it is going to sort them according to the first and last names, and this is basically initially in a different order than the sorted one. So I will go over this example again in the next lecture. I'll see you next week.